So for the problem sets, what I'm going to try to do with this first one is solve for you problem by problem an old problem set. So the problems are not going to be the same, but they're more or less the same. And after I get done talking through the sample one, then we'll actually look at the actual one and just talk about some strategies. Now, to put it quite simply, problem sets are what define intermediate microeconomics and intermediate macroeconomics, to be honest. It's not exams, it's not even the multiple choice homeworks, although those are both important. The problem sets are really what define that greater level of maturity in economics. So let's start looking at this first one. So, again, and I'll post these practice questions. These are obviously from 2006. So some of you were just mere toddlers or children when I made this. I don't even remember this far back. Um, that makes me old. Okay, let's look at this. Natasha is attending rock concerts and cola, and this is her utility function. Now, the idea is that we could graph a indifference curve with this function, but let's not get ahead of ourselves here. Let's start with this first. So, price of cola is equal to 1. Price of concerts is equal to 30. Income is equal to 300. How many colas and tickets should she buy to maximize utility? Okay, so how would you solve this? Well, this would be where you set the marginal utility over the price ratios equal to each other. So we know these two already, price of cola and price of rock concerts. That we're all good with. Okay, now we need to solve the top part. So we need to, you know what's going to be easy here? This is going to get really complicated really quick if I don't. I'm going to start writing it down here. Okay, so for this, to solve for the marginal utilities, we need to find the first derivative. Now, I know that calculus isn't a requirement for this course, but most of you probably have taken some, maybe even pre-calculus. But let me just show you what you need to do here. You basically are going to um, use the power rule here. So what we're going to do here, if we want to solve for MUC, that means we're going to take the first derivative of this function with respect to c. So what that means is that the exponent is going to go out in front, and then we're going to have to subtract 1. So that means it's going to be 0.9c negative 0.1. And for marginal utility with respect to c, nothing changes with the r because the r is unaffected. There's no c in that variable. We can then find MUR, which would just be c to the 0.9 because it's unaffected by this rule, times 0.1 r to the negative 0.9, right? Because I took the 0.1, put it out in front, and then 0.1 minus 1 is equal to negative 0.9. We can just rewrite this and put the 0.1 out in front, c to the 0.9 r to the negative 0.9. And that's MUR. Okay, so now we have an idea of what our ratios are, but let's try to simplify this a little bit here. 0.9 C negative 0.1 r to the 0.1 over 0.1 C to the 0.9 r to the negative 0.9. So this is basically MUC over MUR, which is equal to MRS, marginal rate of substitution. The slope of the indifference curve. 0.9 over 0.1, that's 9. C to the negative 0.1 over C to the 0.9. So remember, if we're dividing them, then we subtract what's in the denominator. And this might be reminding you of some of the rules of mathematics here. So that would mean 9 C to the negative 0.1 minus 0.9 which is essentially negative 1. And then we would have r 0.1 minus negative 0.9, which is essentially positive 1. So that would mean 9c to the negative 1 r to the first. Or 9... now let's just keep it here. 9c to the negative 1 r to the 1. And the optimal point would be where the MRS equals price of cola over price of rock concerts. So that would mean that's where 9c to the negative 1 r to the 1 equals 1 over 30. Nine times 30 would be 270. 9 times 30. So that's going to equal c to the negative 1 r to the 1. And c to the negative 1 is 1 over c. Cross multiply, 1 over c equals 1 over 270r. Thus, let's see here if it's going to let us. We need more space here. Ha ha ha, I tricked you, Word. Or Google. Essentially here, C is going to equal 270R. Then we can substitute and start to solve. 9 times 270R to the negative first, following this right here. 9 times 270R to the negative first, so I just substitute the C for 270R, times, to the negative 1, times R to the first equals 1 over 30. 9, 1 over 270R, r to the first. So all I did here is just took it to the negative 1, which just meant putting that in the denominator, equals 1 over 30. And essentially, 9 times 1 over 270r, that simplifies to 1 over 30. So r equals 1. Then c to the negative 1 times 1, substituting that r for 1, equals 1 over 270. 1 over c, since that's negative. 1 over c equals 1 over 270. C equals 270. And so we find here that the optimal, to actually get to what the question was here, how many colas and tickets should be bought to maximize utility? Well, that would be 1 and 270. What happened to my r equals 1? It's lost. Okay, we'll have to go back to that part in the video. Now, part B, oh, there's my r over 1. I don't know why it's there. Part B says, suppose that the promoters of rack concerts require you buy 4 tickets or none at all. What would happen here? Well, in this case, they wouldn't buy the 4 tickets, so you would need to have kind of an explanation that under that situation, they wouldn't buy it because we already know that their optimal quantity is 1. The other alternative of what you could do is you could calculate the total utility with with 4 concerts and 180 colas, or 0 concerts and 300 colas. Let's just do that really quick here. So that would mean U of 0, 300. So it means 0 rock concerts, 300 colas would equal 300 to the 0.9, 0 to the 0.1. I need my calculator here. That would equal 169.59. And then U for 180, because that would mean going to the rock concert 4 times, so it'd be 4 times 30, so it'd be 120, leaving me with $180 left. So that would equal 180 to the 0.9, 4 to the 0.1. That gets me 108.24 for total utility. So they obviously would prefer, from a utility perspective, this amount right here. Okay, that solves number 1. And there's got to be probably at least one of you who's like, holy crap, like that was a lot of math that I didn't anticipate, which is totally fine. Well, I shouldn't say it's totally fine. It's totally expected. Let's go and look at the actual problem set. Find the question that would be inspired by you doing that one. Okay, so you wouldn't use that for this. You wouldn't use it for this or this. But you would use it for number 6. And actually, you can see an error here. I didn't put in the utility function, so I'll have to add that. Let's make something up here for this. Let's do. I'll have to email everyone this, but um, okay. So let's do this. I'll email everyone this, but let's make up a function here. So let's say that's our utility function. And that the price of chips was 25 cents and the price of salsa was 50 cents. So I didn't change that. Or sorry, not salsa, soft drinks. I don't know why I thought salsa. Because I want to eat salsa. Okay. Part A asks, in maybe a little bit simpler fashion for you here, what is the marginal rate of substitution? What's that expression that can describe that? So you would use the exponent rule to find the first derivative. So you'd need to find the marginal rate of substitution, which is simply mux over muy. Mux, you're going to make use of the power rule. You're going to take this 2, put it in front. Then it's going to be 2 minus 1. Then you're going to do muy. And the exponent rule to find the first derivative would mean you would take this 3, put it in front. 3 minus 2. So now it would be y squared, x squared, 0.3 times 3. Then have them divided by each other because it is a ratio, and simplify. That's going to get you your marginal rate of substitution. Then, in part B, it says, use the expression generated in part A to determine the optimal mix of soft drinks and chips. So now this is very similar to what we had just solved. So in part B, you're going to set the ratio of the prices equal to the MUX you found in part A and the MUY you found in part A. Cross multiply and solve for X and solve for Y to find your optimal amounts. Now, the way this is going to work for the problem sets is, yeah, I want you to get stuff right. I mean, that would make me happy if you get stuff correct. But at the same time, I just want to see that you're putting in the time. Because what's going to happen is that after you do it, I'm going to then release the answers and I'm going to walk you through how to do it. And that'll be the learning process. So I don't want you to think that I'm grading each question based on did you get it correct or not. Obviously, getting it correct is useful, but it's not the be all end all. In part C, to this question. We're told if Jane has $5 a week to spend on chips and soft drinks, how many of each should she purchase? Well, this one's interesting because then what you're going to do is you're going to set up the budget constraint. So 5 equals 0.25 and the x that you found in part B plus py, which right is the 50 cents, the soft drinks, times the y that you found in part B. And if you want to make your life a little simpler, you can't have two unknowns here. So keep this x here and just use your y, which is going to be described in terms of x, and substitute that x in here, and then just solve for x. Otherwise, you'd have two unknowns. So you should only have one unknown here, so you can solve for it. And then once you solve for the one, you can get the other. So my suggestion for number 6, part C, is just substitute in the y that you found, because that's going to be in terms of x, solve for x, and then solve for y. Let's go back to the beginning ones of these, because these you might not need a practice problem set for. Maybe it would be useful if I just talk about it. So this is from the actual problem set. So in number 1, and this actually happened. This was Ted Koppel, who was a pretty famous at some point, a pretty famous news reporter. And the big thing in the 80s was the war on drugs. And one of the things he had said was that the price of cocaine is down, the price of marijuana is down, and he said you don't have to be an expert in economics to know what happens when the price goes down. It means more stuff is coming in. So translate. So letter A says translate what he's saying. Um, the way to think about number 1 is to think about it in terms of comparative statics. What is Ted Koppel saying is the reason for why the price went down? That's what letter A is. Letter B would be, well, how would we know that he's right? Like, what kind of test would tell us that he is correct? Letter C is basically, what would be the other ways that I could get the price to come down? There are alternative ways, right? Shifting other curves in other directions. So that's what you would say in letter C. Number 2, Lisa is viewing pizzas and burritos as goods. She prefers 4 burritos and 4 pizzas to a bundle of 4 burritos and 5 pizzas. Which assumption of consumer preferences is violated? What change in the assumptions could lead a rational consumer to prefer the first bundle? So in this one, what you're basically saying, right? We have to go through the 3, or possibly I argued that there's 4 assumptions. But which of those assumptions would be violated by having a 4-4 being preferred to a 4-5? And what are we assuming if we were to say that 4-4 is actually preferred over 4-5? What would have to be the nature of a pizza that would make a person prefer a 4-4 to a 4-5? To give you a really big hint, since you've been watching this video this long, um, what if pizzas were a bad good, right? What if they were a harmful good? Then you would want less of them. That is actually the answer to that. Okay, number 3 is asking you to draw indifference curves for rock concerts and foods for a 17-year-old and a 75-year-old. So, you're just going to play around with this here and just draw them out, right? Normally, 17-year-olds like both of these goods, right? Sorry, I can't draw on this. 17-year-olds would like both of these goods. So their indifference curves might look normal, right? They might just be um, the regular convex to the origin type of indifference curves. But 75-year-olds don't typically like rock concerts, typically. So you could either draw it where the rock concerts are a bad good, or you could draw it where they're neutral to food. But that would give you, you could draw them out for a 75-year-old looking like that. Okay, I'm kind of deviating now away from the practice, at least for now, for the first problem set, just because um, I'm worried you might be really scared after I just did number 1 here. Um, so here, um, you're again doing comparative statics, and you basically, I'm giving you events that are happening, and you just need to know which curve or curves do you shift, and then what direction do you shift it. And then that'd be where you would tell me what's happening to the equilibrium price and the equilibrium quantity. And that would mean that it's either increasing, decreasing, or staying the same, unknown. Um, sorry again. Um, where you would talk about, um, I really am sorry for having to blow my nose. But I think you're tolerating me because I'm helping you. So, and others of you are now saying, well, dude, that's your job. So it's not like you're helping us. You're just earning your salary, which I guess is also true. But in number 4, you're just basically doing some comparative statics to try to solve this. Number 5. So for number 5, this is going to take you back to your Econ 130 days. How do we solve for equilibrium? Well, what we have to do here is we have to set demand equal to supply. So you would need to set the 1600 minus 125p equal to 440 plus 165p. Solve for p, and then substitute p to find the quantity. Okay, part A, easy. Now we get to part B. And I ask you to tell me what the price elasticity of supply and demand is at those equilibrium values. Let's go back to this. Okay. Let's just walk you through it. If you're watching it this far, you might as well get this right. Okay, so add 125p. Minus 440. And then I would get 1160 equaling 290p. Divide by 290. P equals 4. and then substitute it into either. I'm just going to do it in this one. Okay, there's my equilibrium price and quantity. That is the actual answer to 5, letter A. Okay. Now for the elasticities, it's E equals B, P over Q, where the B is the slope term. So for elasticity of demand, my slope term is right here. So that'd be negative 125 4 over 1100. Which is equal to negative 0.45. Negative, I'm not too surprised there because elasticity of demand is always negative. 0.45, that tells us it's inelastic. I'll let you do the supply one. Yeah, we'll make it fun, right? Okay, let's go. Back to the problem set. Sorry, I gotta find it here. Okay. And we did 6. 6 is probably the hardest here. Let's work on number 7. Um, so barbecue plates were 450 each and sold 525 customers during the week. When she reduced the price to 350, she then got it to 600 plates per week. So what we need to do here is we need to solve for the percentage changes. Let's go to my work page here. Get some more space here to work on something. So elasticity demand is the percentage change in the quantity demanded over the percentage change in the price. Um, what is the percentage change in the quantity demanded? Well, I like to use the new minus old over old times 100 kind of notions. That'd be 600 minus 525 over 525 times 100 equals 14%. And then for the percentage change in price, again, I like to use new minus old over old times 100. So that means 350 minus 450 over 450 times 100 equals negative 22%. So that means that the elasticity of demand then is the 14 over the negative 22, which is equal to negative 0.63. Well, I solved it for you, but it's just so exciting to solve it. I just get excited about solving problem sets. Um, well, I'll let you work through the rest of this, but yes, that's. We did part A. I'll let you do part B in terms of that revenue test. And then price elasticity of demand for gasoline is estimated to be 0.2. This should actually be negative 0.2 because it would have to be negative. 2 million gallons are sold at the daily price of $1. Use this information to calculate a demand curve. So now it's kind of like we're doing the reverse here. So now it would be, again, I said that it would have to be negative here. Negative 0.2 equals B P over Q. We don't know the B. We know that the P is 1, and we know that the Q is 2 million, and that's negative 0.2. And you can then solve for B. Once you solve for B, once you find B, then what you would do is you would set up an equation where 2 million is your left-hand side of the equation, and that would equal x minus your B times P. And you would then solve for, you'd already found the B over here, so then you would just solve for x. Okay. I think I've given you enough information now to kind of solve, to get, to make problem set number one pretty successful. Sorry, I kind of deviated here. I actually think it was a little bit more effective to not do the practice problem set and just kind of give you some steps to think through this. So I think I might just adopt that strategy for the remaining problem sets. Just bring it up and just kind of talk you through them, give you something to work with, and then let you struggle through the rest. Okay, that ends my video for problem set number one.